Hi guys, my name is Longdi Zhang. My student ID number is 5156404. This one. Okay, let's start my presentation. Here is my presentation about a historical simulation and module building in the estimation of a VAR. What is a VAR? VAR, which is a value-added risk, referred to the maximum amount of money that can be expected to be lost over a given period of time and at a given confidence level. In the part A of the assignment, I use two approaches to analyze VAR. One is historical simulation, another one is module building. Okay, let's start. Historical simulation refers to the calculation of a current portfolio rate of a return based on the historical rate of data of each asset. Rank historical returns from lowest to the highest. So the rate of a return at a confidence times n is an estimation of a VAR. The historical simulation method assumes the market variable follows the distribution given by the historical data. In part A, I have following the results shown on the slides. The interpretation is quite straightforward. If we invest 10 million in portfolio, we would expect there's a 1% chance of losing $1,221,955.83 or more in this investment. If we invest 10 million in portfolio, we would expect the 10% chance of losing about 460,000 or more in this investment. Okay, going on the advantage, historical simulation is a simple method of a generation scenario. It is a relatively easy to calculate day-over-day change in market data and apply them to current market data. Second, all historical mean value volatility and correlation are embedded in the historical data itself and the module including them without any extra effort. Third, there's no need to assume distribution for the data. The final advantage is popular and easy to explain. Okay, going on to the disadvantage. First, we assume the historical data will repeat, which is not realistic. And next one is a historical contain special event. For example, like a financial crisis, which is a method is not realistic. The third one is the one-day VAR often scale up to the n days by simply multiply the one-day VAR by the square root n. Scaling this way also neglects portfolio efforts. First, it is a slowly measured and is a easy incorporate volatility updating schemes. The module building method is different from the previous method. The module building approach assumes the market variable following the multivariate normal distribution. The result I get in the part A is as following. The interpretation is if we invest 10 million in the portfolio is the same to the last one, we would expect there's a 10% chance of losing about 810,000 or more in this investment. It is higher than historical simulation. If we invest 10 million in portfolio, we would expect there's a 1% chance of losing about 1.47 million or more in this investment. Is lower than historical simulation. We can see that distribution of two methods is quite different. One following the historical distribution, another one following the normal distribution. Okay, advantage variance of a covariance method is fast and simple to implement. Another one is a less historical data requirement. Disadvantage relies on normal distribution assumption, which might not realistic. Second, it assumes historical correlation are stable, which might not realistic. Third one, the method will be inaccurate if large change in the price of financial instrument in the market needed to be measured. The last one is it is not easy to explain and not popular among the investors. Okay, to sum up, VaR is quite useful in the financial trading. First, it makes the risk of financial activity comparable. Second, it makes the risk measurable in monetary terms. The final one is considers the relationship between different risk factors. Okay, that's my presentation. Thank you everyone to listening. Cheers, everyone.